Welcome students, we come back again with a new video that can give enough knowledge. So let's start. Today we discuss the topic, this one is grouping of cells. Okay, the first part, cell in series. Cell, that you know, what is cell? That means within the cell, this is the symbol of a cell. This one is positive terminal, this one is negative terminal. So when it is connected in the circuit, obviously current flowing in the positive to negative terminal, there is the current flowing, and the electron flowing in the negative to positive terminal, that is along that direction, completely opposite. Okay, so when this cell, consider this cell is 1.5 volt, but we require more than voltage, that is now we require more current in this case. So when we needed more current, so we just assemble more number of cells in maybe series, in maybe parallel, to get the value of the current is greater than that of the previous one. Okay, so whatever we can get that. So just check it out here, number of cell connected here, this is the first one, second one, third one, and n number of cells connected, this is the n number of cells. Okay, all these cells are connected in series. When the number of cells is connected in series and it is connected with the external resistance R. Okay, so now this is the complete structure or circuit diagrams for the group cells connected in series. If I consider the internal resistance of each of the cell, this is the has some EMF. Okay, but within this cell there is an internal resistance. Due to the internal resistance, its original EMF decreases and its potential value V obviously less than the EMF. Clear? So internal resistance is the part that is present within the cell, and due to this cell, this original EMF is decreases to the value of the V, that is the potential difference. So when it is in the closed circuits. So here the total number of cells connected, this one is AIE, that is the n number of cells. So total EMF, if I write total EMF equals to, so n number of cells connected, each of this EMF is E, so that is equals to n into E. Okay, total internal resistance, what is the total internal resistance? What is the total internal resistance? Internal resistance for each cell, that is equals to small r. Okay, here n number of cells connected, so total internal resistance, that is equals to n into small r, so that is equals to nr. Clear? So now these resistance are connected in series one after another, because cells is connected in series, it is connected with the external resistance capital R. Okay, so therefore the total resistance, that is equals to R plus NR. This one is the total resistance in the circuit. Now when these cells, all these cells are connected in series, so total resistance, this one is R plus NR. So according to the Ohm's law, we know that V equals to IR, so I equals to V by R. V is the total EMF, here total EMF equals to NE. Okay, and R is the total resistance equals to R plus NR. Clear? So I equals to NE by R plus NR. Now two conditions arises in this case. This is the very much important. For first one, that is the case 1. If I write case 1, that means when R, that means R is less than NR. When R less than NR, so we neglect R, this one. When we neglect R, so I can be written as NE by NR, because R is 0. So this one written in the form, that is NE by NR. So NE by NR, NN cancel out, that is equals to E by R. So just check it out in this case, I equals to E by R. That means current I equals to E by R. N does not included in this case. Does not included means, that means if I increases number of cells continuously, 1, 2, 3, 4, 10, 15, whatever, but total current remains fixed. It does not depend on the value. Which value? That is the N. Okay, so if I connected 1 cell or 10 cell or 20 cells, whatever, the current remains fixed throughout of it. So in this case we neglect this part, because this is not effective. We connected 10 or more than number of cells, but the current given by this positions or given by this circuit, it is not appropriate, because it does not depend on the value of the N, that is the number of cells. So we move to the next case, that is the case 2. So last we discussed about the case 1 part. Okay, you positively write this part. Now you move to the case 2. So same thing, here we consider the external resistance R, it is greater than NR. Okay, here n number of cells in internal resistance is NR. Okay, R is the external resistance. When R greater than NR, so I from these equations we just neglect the NR, this is equals to 0. So therefore I equals to NE by R, this one, that means N into E by R. What is E by R? That is the EMF of the single cell. Okay, and N into E by R, that means N is the number of cells. Here we connected, consider 10 number of cells where N equals to 10. Then when N equals to 10, current is 10 into E by R, that is original current is increases by 10 times. So in this way, if I write N equals to 20, so it is increases by 20 times. That means current increases by increasing the number of cells. That is, when we increase the number of cells from 1, 2, 3 up to 10, 20, whatever, that means the current is increased that times, that is 10 times, that is 20 times, whatever. Okay, so this is very much effective. That is, current in this case depend on the number of cells. Okay, number of cells increases, current is increases. That means N is increases, number of cells is increases, then current is also increases in this case. Okay, N is decreases, that is the number of cells decreases, current is also decreases. So this is the main part for the grouping of cells for the series. Now we move to the next part, that is the parallel grouping of cells. So next we move to the next part, that is the cells in parallel. Here number of cells connected, this one first, second, and number of cells. How many times? That is the M number of cells. Okay, so this one is 1, first cell, second cell, this is the M number of cells. M number of cells connected one after another in parallel. Parallel, that means there is a starting and ending point, both are same. So here we connected the external resistance R. Okay, so we repeat once again, that is the number of cells, this one 1, 2, 3 up to n number of cells connected in parallel. Parallel means starting point A and ending point B, both are same. And external resistance capital R is connected over there. Okay, so here it is a parallel combination, that means the EMF is fixed. That is the EMF potential difference between A and B is remains fixed because the parallel combination, there is no voltage drop. So here it is the value is E. Clear? Now, so we just write here, that is the total EMF. Total EMF equals to capital E. Okay. Now here all the cells are connected in parallel. So therefore, if I find out the total resistance, total internal resistance. So total internal resistance, what is this? Consider this one is R dash. So 1 by R dash, all these are connected in parallel. So we just write 1 by R plus 1 by R plus dot dot up to M times. Okay, so we just write that is the M times. So that is equals to M by R. So this is the total resistance. Okay, internal resistance. So R dash equals to R by M. This is represent the total internal resistance. This is the total internal resistance. Total internal resistance. Now what is the total resistance? Total resistance, this one obviously equals to R, external resistance is R and internal resistance is R dash. So R plus R dash. When R plus R dash we added together, so we just get R plus small r by M, this one. Okay, R plus small r by M. So this represent the total resistance. Okay, EMF is E, total resistance is this one. So what is the current? Current we just write, current in this case I equals to E by total resistance, that is E by R plus R by M, this one. Okay, now we move to the two cases, again same, just like that series. So what is case 1? Case 1, consider that is the external resistance R is greater than R by M. When external resistance R is greater than R by M, so R by M tends to 0. So we just write from this part, that is I equals to E by capital R, simple, because external resistance R is greater than R by M. So it is much greater. When it is much greater, that means R by M is very less. So we just neglect the R by M. So I equals to E by R in this case. Okay. Now same case, that is we write, that is the case 2. Case 2. So that means case 2, the opposite of this, that is R is less than R by M. That means when R is less than R by M, so that means R equals to 0. So that means I equals to, represent in the form, that is I equals to E by simple, that is R equals to 0. So that means R small r by M, that is equals to M into E by R. So here E by R represent the internal resistance of the first cell, single cell, okay, and M is the number of cells connected in the parallel. So just check it out. I is M times, that is the E by R, that is M is increases, that is the number of cells connected in parallel, it is increases, then current is also increases, just like the previous one. But for the, in this case, the opposite, for the series, here it is for the parallel, just say that is R is less than R by M, that is external resistance is less, then the parallel is effective. What I say, external resistance is less, then parallel resistance is effective. Okay, so we just write here, you just memorize this part, that means external resistance less then parallel combination is more effective. And for the series, this one is the parallel combination. For series combination, same thing, external resistance, that is the capital R is greater, okay, capital R is greater then series combination is more effective. Okay, so you just remember the two keywords, this is very much important. External resistance is less, that means R is less. When R is less, parallel combinations is effective. When R is greater, that is the series combinations is effective. Okay, so now we move to the next part, that is the mixed grouping of cells. So move to the next part, that is the grouping of cells. Next one, that is the mixed grouping. Here number of cells for the first line, they just check it out, n number of cells connected in parallel series, that is this one, first, second, up to n number of cells. Second one, here also the next number, n number of cells. In this way, n number of cells continuously connected in the series. Okay, total number of row in this case, this is the first row, second row, third row, in this way. So total number of row is m, that is total m number of line are connected, okay, in parallel manner. So if I consider this one is A and this one is the B, okay, we consider the first line, this is very much important. So total EMF equals to, obviously for the first line we consider total number of cells, here n, for one cell the EMF is E, so total EMF, that is equals to n into E, this one. Okay, so this is the total EMF. Now we want to find out, that is the resistance. Okay, total resistance, total internal resistance. For the first one, the internal resistance is smaller. Total for what this line, total internal resistance, that is equals to NR. Okay, so this one may be written in the form, that is the, if I write the total resistance R dash, total internal resistance, so obviously this one, all this line, this NR, it is also NR, this one also NR, all this NR number of resistance are connected in the parallel. We repeat once again, for the first line NR number of resistance present, second line NR number of resistance present, third line, fourth line, last line NR number of resistance present. So all this resistance are starting point, ending point are both the same, so connected in parallel. So we just write here, this one is NR plus this one is NR plus NR, how many times? That is the n times, rotated up to the m times. Clear? So what is the value in this case? That is 1 by R dash equals to m by NR. This is the total resistance, internal resistance. So now R dash equals to, R dash, what is the R dash? That is the total internal resistance, R dash equals to N into R by M, this one. Okay. So what is the total resistance? So total resistance, that is equals to external resistance is R, internal resistance is R dash. So obviously R plus R dash, that is R plus N into small r by M, this one. Okay. So this represent the total amount of resistance, total amount of resistance in this case. So we just want to find out that is the value of I. So I equals to total EMF. What is the total EMF? Total EMF equals to NE. So that means NE by this one, that is R plus NR by M. Okay. So that is NE by, if I multiply it with this M, that is M into R plus NR. This one is I. So that is equals to M into N into E, that is by MR plus NR. Okay. So here now M into N, this is the total number of cells. If I represent the, it is capital N, because N, that is the number of cells in one row. Okay. How many row is present? That is M. So M into N represent the total number of cells. So this may be written in the form, that is capital N into E by MR plus NR. Okay. Up to this clear? Now again we come to the point, that is the same two cases, that is the case 1 and case 2. Now here if I write in this case the value of MR plus NR, so MR plus NR equals to, it may be written in the forms, that is root over of MR whole square plus root over of NR whole square plus 2 root over of MR into root over of NR, this one minus, so if I write this one is minus, so this one is also plus 2 into root over of my MR into 2 root over of NR, because for balancing MR this one is given, so root over of MR square, so this is represent this, NR root over of NR square, so this represent this also. Okay. And if I write minus 2AB plus 2AB in the forms, so for the first 3 we just may be written in the form, that is root over of MR minus root over of NR whole square plus 2 root over of MR into NR. Okay. So this is the part we write, this one. Okay. Now we form this current I. So what is I? I equals to NE by MR plus NR. So I equals to NE, so we just write from this part, that is NE by MR plus NR. MR plus NR equals to this one, so it may be written in the form, that is root over of MR minus root over of NR whole square plus 2 into root over of M into N MR into NR. Okay. Now two cases arises in this case, that is MR plus NR, this one is maximum or minimum, what we write in this case. Okay. So so case 1, if I write, when MR plus NR, this one is minimum, MR plus NR is minimum. When it is MR plus NR minimum, this equals to 0, that is root over of MR minus root over of NR equals to 0. When MR plus NNR, that is equals to 0, so it represent, that is root over of MR equals to root over of NR. So that means this one root cancel out each other, so that means MR represent this one thing, this one is smaller, so this one is smaller, this one also small, MR, this one capital R, and this one is smaller. All this part of the NR, this one is small. Okay. So we just change it at first. So this one is also smaller, So root over of mr equals to root over of nr. Okay, so that is m into capital R equals to n into small r. So this one is the part. So that is the external resistance equals to n into small r by small m. Okay, now in the previous case internal resistance equals to n into r by m. Just check it out. When this part is 0, that is the lower part is 0. When lower this one is 0, then I is maximum. When so we just want to find out the I is maximum. I, that is the maximum when this part is minimum. Okay, so this part is minimum, that is mr plus nr. This part mr plus nr, this is min. Okay, so this is minimum occur only when that is r equals to nr by m, this one. Okay, so that is the external resistance equals to nr by m. Here we just check it out, the internal resistance also n into r by m. So both are same. When external resistance and the internal resistance both are same, then for the mixed grouping it is effective. Okay, so we just discussed the part, that is the external resistance and the internal resistance both are same, then the mixed grouping part is effective and it gives the maximum current. Maximum current, that means the lower part is tends to 0. When lower part is 0, when the external and internal resistance are both are same. Okay, so now today we discuss the following parts, that is the series. After that there is the parallel. Now we discuss the mixed grouping of this case. You just all the students positively write all these parts in your copy and read this part is very positively. Okay, so thank you again. Thank you. Watch my video and subscribe my channel. So thank you everyone.